Okay, this is a very important part of curved mirror. Image is formed by curved mirror, be it concave mirror or convex mirror. But here we are going to start with images formed by concave mirror. It is very important to know that the images formed by concave mirror depends on the position of the object. As the object changes position, the type of images that is being formed also changes. Why is it so? It is so because both the focal point and the center of curvature of the curved mirror, they are all in front of the mirror. And hence, object must also be in front of the mirror. So because if you want to look at yourself in the mirror, you don't turn the back of the mirror, you look in front of the mirror. So the object, the focal point, and the center of curvature are all in front of the mirror. Therefore, once this object changes position, the type of image formed will also do what? Change. So we take a look at the first one, when object is beyond the center of curvature. So we can see the focal point, we can see the center of curvature, and we can see the object standing. So how do we know the type of image that is being formed? We make use of the ray diagrams. The first one states that when a ray is parallel to the principal axis, it has to reflect through the focal point. So what is going to happen here is that this ray here is parallel to the principal axis, hence it is going to reflect through the focal point. And the second one says that when the ray passes through the focal point, it has to reflect parallel to the principal axis. So this is what is going to happen. The second ray passes through the focal point, and on this point it has to do what? Reflect parallel to the principal axis. And the intersection of these two reflected rays is where the image is going to form. So let us take a look at the type of image that is being formed here. As you can see, the foot of the object and the foot of the image, they are both supposed to be on the principal axis. Hence, you can see that the image is inverted. Now, remember that whenever the image of the image formed by a mirror is in front of the mirror, that image is real. So let's take a look at the type of image that is being formed. Number one, the image is in front of the mirror. Hence, the image is real. Number two, you can see the object is standing up while the image is pointing down. So it means that the image is inverted. The third one is, what is the size of the image? You can see that the image is smaller than the object. So we say the image is diminished. And finally, where is the image formed? You can see that the image is formed between the focal point and the center of curvature. So formed between F and C. Please, if you are writing this thing in the exam, don't write F and C. Use focal point and center of curvature. So I repeat again, when an object is placed beyond the center of curvature of a concave mirror, the image must be real, inverted, diminished, and formed between focal point and the center of curvature. This is important to know because when we start the calculation part, all these things are going to help us. Number two. Okay, number two, when the object is at the center of curvature, what is going to happen? You can see this is the focal point and this is the center of curvature. So we repeat the same thing. The first ray is going to be parallel to the principal axis and it has to reflect through the focal point. And the second ray is going to pass through the focal point and it is going to reflect parallel to the principal axis. And we can see the point where these two intersection. That is where the image will be formed. So here, when the object is at the center of curvature, image is, again, it is in front of the mirror. Hence, it is real. Secondly, it is inverted. Third, it is the same size as the object. And where is it formed? It is formed at C, center of curvature. So this is a very important part of curve mirror. Whenever object is at the center of curvature, the image will be real inverted, very, very importantly, the same size as the object, and also formed at the center of curvature. Okay, the third type of image that is being formed by a concave mirror is when we place the object between the focal point and the center of curvature. If you look at all these images, all these objects, you can see that the object began from being beyond the center of curvature, and it is now coming closer to the mirror. The first one beyond center of curvature, the second one at the center of curvature, the third one between the focal point and the center of curvature. So let us take a look at the type of image that is going to be formed again. Number one, we have the ray parallel to the principal axis again. How is it going to reflect? It is going to reflect through the focal point. Secondly, we have a ray that passes through the focal point. How is it going to reflect? It is going to reflect parallel to the principal axis. We can see the point of intersection here, and the image is formed here. And what type of image is formed? From our diagram, you can see that image is real because it is in front of the mirror. Image is inverted from the diagram. You can see that. What is the size? You can see that the image is now bigger than the object. We say image is enlarged. Either you use enlarged or you use magnified. They are both the same thing. And where is the image formed? The image is formed beyond the center of curvature. So you can see that from this diagram, this is just the opposite of the first diagram. The first diagram is that the object is where this image is, and hence the object is bigger than the image, and the image is formed between F and C. And now, when you now place the object between F and C, the image will form beyond the center of curvature. So you need to know all these things, because when we start calculations, we apply all these things in our calculations. The fourth one here is when the object is at the focal point. What will happen? Let us see what will happen. First, again, there is supposed to be a ray parallel to the principal axis. Where is this ray going to reflect through? It is going to reflect through the focal point again. Now, the second ray is supposed to pass through the focal point, but the image is already at the focal point. So there is we are not going to have any ray passing through the focal point. And hence, we use the third ray diagram, which is the ray that passes through the center of curvature. It is going to go this way. Please pardon my sketch. This is just sketch. So the ray that passes through the center of curvature, incidents through the center of curvature, it is also going to do what? Reflect through the center of curvature. You can see from this diagram that these two rays are parallel. They don't intersect like the other rays we have done. And hence, you can see that these two rays are parallel to each other. They don't intersect as the other diagrams we've done. And what does that mean? It simply means that in this particular aspect, no image is formed. So whenever an object is placed at the focal point of a concave mirror, no image is formed, or we say the image is formed at infinity, and we know what that means. Let's take a look at the final type of image. Okay, so this is the last type of image that is formed by a concave mirror. You can see we've exhausted all the positions. The object is now between the focal point and the pole. That is the focal point and the pole. Or you say the focal point, the object is between the focal point and the mirror. So what is going to happen? First of all, again, we have a ray parallel to the principal axis, and it is going to reflect, it is going to reflect through the focal point. Now, secondly, we are now going to use the ray that passes through the center of curvature. And as we can see, it is this way. So, remember, it will incidence through the center of curvature, and it will also do what? Reflect through the center of curvature. That is the third ray diagram. So, when you take a look at this, you can see that they are not parallel, but they don't tend to meet at this part. So, what it means is that at the real part, the two rays are diverging. So, if they are going to diverge at the real part, and they are not parallel, so an image has to be formed. It means that this image is not going to be formed in front of the mirror. Hence, the image is now going to form behind the mirror. So the image is going to form at this point. So from the look, if you take a look at this diagram, you can see that whenever an image is formed behind the mirror, we say that the image is virtual. Remember, virtual images are images that are formed behind the mirror. So take a look at this. Is it inverted? No. It is upright. So, as long as mirror is concerned, all virtual images must be upright. Because in calculations, they would want to confuse you. Instead of calling it a virtual image, they will call it an upright image. Just know that when images are virtual, they must be upright. And when images are real, they must be inverted. What is the size of this image? You can see that the image is bigger than the object. So we say it is what? Enlarged. And finally, where is it formed? It is formed behind the mirror. So this is the important type of image that is being formed by a concave mirror. So from all these things we've done, you can see that a concave mirror forms 5 types of images depending on the position of the object. And between these 5 types, from what we've done, you can see that a concave mirror forms 4 types of images. And between these 4 types of images, 3 of them are real and 1 is what? Virtual. The only time a concave mirror is going to give you a virtual image is when the object is between focal point and the pole. It is very, very important to note this. And again, we have a point where the object is at the focal point, no image is formed. We take a look at image formed by convex mirror.